Hello, I'm Yubri from Smallfish. Welcome to Fish School 2.0 Episode 2. Last episode we started creating our player, so let's get back to it. Let's start by tidying up, grouping these properties into their own category with the category attribute. We've got a components category and a stats category. We can collapse them in the editor now. Now let's move on to onFixedUpdate, where we'll move our player. We first add a null check for the component before trying to access it, that way if it's missing, we won't get errors. Let's generate the wish velocity our player is going to have based off of their inputs. Fetch the player's inputs with the vector input.analogMove, which works for WASD and all type of controllers. You can change your game's movement inputs in your project settings, we'll see that later. W and S control the X value, A and D control the Y value. Then, multiply it by our walk speed. Usually, since we're using units per second inside of this context, which runs every tick, we would divide by the number of ticks per second, or multiply them by time.delta. But the character controller takes that into consideration already, so we won't have to. Just remember, if your movements are way too fast or way too slow, then it's probably that. Accelerate the controller towards our wish velocity, kinda like lerping it. If you wanna change how fast your movement accelerates, then you can modify the controller's acceleration property. If the controller is touching the ground, then we apply a friction to stop our player from sliding once they stop their inputs. 5 feels like a good amount for me. If it's not touching the ground, then we apply gravity to bring it back down. Since falling for longer makes you fall faster, we manually add the scene's physics word gravity to the controller's velocity. And as you can see, we are multiplying by time.delta, because we are running this code 50 times a second, while the gravity variable is meant to be represented in units per second. If you wanna change the gravity, I don't think it's been exposed yet. I couldn't find it myself. And now that we're done calculating what we want our controller to do, we apply it with the move method, which is going to do all the complicated math to get the root game object, in our case the player, to move and collide with the world. Save, and let's boot up in game. Let's just move this back onto the plane. We can move around and collide with the cubes, but what you're not seeing is that the inputs are all jumbled up. That's because right now we're moving relative to the world and not relative to the player. Let's fix that right now. We're going to create a new variable on our player called eye angles to keep track of where they are currently looking at. Then, we're gonna move to handling mouse movements inside of the onUpdate method since it needs to feel smooth. We add to our current eye angles input.analogLook, which returns how far your mouse or analog stick moved in the last frame. Let's access the player game object's transform, which holds all the information about position, rotation and scale, and here we take the rotation and set it to the eye angles yaw to point where they are currently looking at. We want our player to rotate left to right, so we can ditch the pitch and roll of the angle. Move back to onFixedUpdate and let's multiply our wish velocity by the player's rotation. With quaternion magic, it will rotate the velocity vector to match our player's rotation. Save and play. As you can see, the camera is also following the player since it's parented to the game object, and we are rotating the player itself. First thing first, we need to bind a key to sprint. We do that in our project settings. Go to Edit, Project Settings, Input, and now you can see all the default inputs and which keys or buttons they are mapped to. Currently, we can just delete most of them. We're going to keep WASD, space, Shift, Control, mouse 1 and mouse 2. Well, how am I supposed to click on the button if it's out of the screen? I'm sure they'll fix that. Oh look, supported control modes. Let's just check the keyboard and gamepad. I'm sure it will work, won't be testing though, test the player's job. While we're at it, let's rename attack 1 to punch and attack 2 to grab. As you can see, the default keybinds already have a sprint key binded to shift, which is called run. Let's save here and implement it. have a wish speed variable. If you are holding down the run key, then we return the run speed, else we return the walk speed. Update the wish velocity with the new wish speed variable and save. Check out in game. Holding shift will now make you run. Epic! We can also edit it live here in the editor. Let's make it super fast and fly off of the platform. Bring it back to 250. Now let's quickly implement a jump as well. Wrap these in some brackets so we can expand on them. Check if we press the jump button, which with input.pressed only returns true the tick or frame your input was pressed, as opposed to having it down like when running. Then, if you did press the jump button, we use the punch method in our controller to shoot the player up by our jump strength. What punch does is basically detaches the player from the ground, then applies this force to the velocity instantly. Usually the controller likes to stick the player to the ground, so they don't just fly down stairs when running, so this method is useful when we actually need to do that. Let's hook up the animations now. Inside of our jump code, if the animator is valid, it's going to trigger the jump animation. If we didn't have the citizen animation helper, we would have to manage all of our animation parameters ourselves. Now, our jump won't look good if we don't tell it that we are not touching the ground anymore. After we let the controller do its own thing, we make sure the animator is not null and then set the isGrounded variable to match the controller's isOnGround one. Now feed our player's velocity in as well, save and play. Awesome, it even plays the landing animation when we hit the ground. Thanks Citizen Animation Helper. A thing that I noticed that almost slipped my mind, we are moving faster when moving diagonally. That's because the length of a vector when moving horizontally is 1. Same when vertically. But combining them, you get around 1.4 of length. Basic math. Let's fix this by normalizing the inputs, so the length is always going to be 1. Another annoying thing, since we're not applying friction when we are in midair, you can strafe like crazy. We talked about modifying the controller's default acceleration earlier, so let's just do that. When we are on the ground, our acceleration will be 10, which is the default. But when we're in midair, our acceleration is only half of that. This way it's harder to strafe while in midair. Save and try it out. Yep, feels much better already. Let's now get a better camera experience, which we're gonna do inside of the onUpdate method, so it's nice and smooth. What we are planning here is to have the camera start out at the position we set it in the editor, store that position, and then use it as an offset to move the camera around the player, so it points always where you are looking at. Set up a variable to store the initial transform, doesn't have to be public since it's for internal use only. Inside of the onStart method, we do a null check, and if it passes, we set the initial camera transform to the camera's current local transform relative to the player's parented on instead of the word. Now, we actually need a position for the camera to rotate around, so let's add a new property on our player, one that will represent this position, which is also going to be used in the future to cast rays. Create a new vector3 property called iPosition, give it a nice description, and now here is a problem. It's going to be hard to pinpoint where we are actually placing this position relative to the player since we have no indication. This is where editor gizmos come in handy. They are a way to display properties and drawing shapes directly into your scene's view. Let's override the drawGizmos method to access the correct drawing context. And using the gizmoDrawStatic property, we are able to make use of all the drawing methods. In our case, a shrimple line sphere will suffice, positioned on the eye position and with a radius of 10. All positions inside of the drawGizmo context are based around the player, not the world, which is why iPosition works. If you wanted to use the world coordinates, then you can change that, but we're not gonna look at it. Save and let's check our component. Close down here before we get any errors. There's the sphere representing our eye position. Let's just edit the Z position to center it around the head. which is where the camera is going to rotate around. If our camera is valid, then we set the local transform to the initial camera transform, but rotated around the eye position using the eye angles, which are automatically casted from the angles type to rotation type. Let's try it out in game. Whoa, this is confusing me. It seems like we are accounting for both the player's rotation and the eye's rotation, but only for the yaw component. Let's just add this to set the yaw on the eye angles to 0. Let's check it out. Much better. Still, it looks like I can rotate my view around too far back. This isn't a camera issue, it's an input issue, and since we want our camera to always represent where we are looking for, we'll have to clamp our eye angles. After setting the eye angles initially, we now set it to a version of themselves with the pitch clamped between -80 degrees and 80 degrees. I'm not going for full 90 degrees because it looks bad. Save and check. Looks good as always. It looks like it's not completely snapping to the degrees we set, but that's because for the initial camera transform, I angled it slightly downwards, towards the ground. All it's doing is taking that into account as well. I forgot to commit my stuff and push them. I'll do that now. I hope you haven't forgotten. What? Yeah, sure. It seems that Gary has implemented a brand new component used to add clothing to your character. Let's check it out real quick. Perhaps it's not the component? Now, instead of using a property to get our component, this time on our on start, let's go through all of our components and try to get the skinned model renderer. If it does find a skinned model renderer component, it will return true, run this code here, and provide us with this model variable we assigned, which will return our skinned model renderer. There it is. This is what Gary just added. We use the clothing container to reference all of the clothing assets and handle all of the body group switching that it's going to need to apply the clothing. We now use this new method called createFromLocalUser, explicitly used for single player games like ours. We're going to switch to something else when we are implementing multiplayer. This is basically going to load all of the clothing assets that our character uses. And now apply all of the clothing we just loaded to our model. Let's save and check it out. Perfect. Works great, just as expected. Great job, Gary. Now going back to the pre-recorded. While you wait for the next episode, you can try tweaking the controller's variables. See which ones you like best. And also, how about you try implementing a double jump as well? The original is not farmhead one, but I'm not going to recreate it. You should be able to easily do it if you followed the tutorial. All you need is probably a new variable that remembers if the player has already double jumped, and that resets when you are touching the ground. Thanks for enjoying our fish tent.